And I'm going to share my screen. And then today is Wednesday, March the 8th. What I hope to do today is first I want to see if you have questions from the prior lesson related to data and its visualization. Hopefully you've maybe had the opportunity to look at that first quiz and see if you have any questions. Then I'm going to introduce you to Minitab because you're going to need it as you begin to work on Project 1 and complete Quiz 2. Then we'll talk about the specific data displays for qualitative data. And then the topic for today's lesson is actually descriptive statistics, missing data, and outliers. And we'll see how far we can get into that. And I'll make adjustments in the schedule accordingly. So do either of you that are present in the room have questions related to the lesson on data and its visualization?
No questions.
I don't think I have questions either.
Okay. Well, since neither of you have questions, then we'll go ahead and begin taking a look at Minitab. Minitab is the statistical software program that we're going to use throughout this course to do all of our statistical analysis. I believe I mentioned in the previous class that nobody, no researcher, no statistician, even biologists or people in the business world do statistical analysis by hand anymore.
I think you mentioned that.
We have technology that will do it for us. A lot of folks will use Microsoft Excel, although Excel was never ever intended to be used as a statistical analysis tool. You can Google and find free websites that will do it. There are a variety of statistical software plans or software packages. There's one called SAS, SPSS, there's Minitab, and I personally learned Minitab when I was coming through school. It was very different than it is today, but in my view, it is probably one of the most user-friendly statistical software packages. And even if you can learn how to use this particular software package and you go to a position or a job or another school that uses something different, a lot of the skills will transfer. So you should have, through Georgia Highlands College, free access to Minitab. So I'm going to go over to Google Chrome, and that is the recommended browser for Minitab. And in the address blank, I'm going to type app.minitab.com. It's app.minitab.com. And you would do the same thing on your personal device. And I hit enter. And it brings me to this sign-in page. You must use your Georgia Highlands email address. Even I have to do that. So I do lralston@highlands.edu. You would enter your Georgia Highlands email address. I'm on my personal device, so I keep myself signed in so that I don't have to log in to Minitab every single time. I click next. It is going to take you through the Duo security. So I enter the password that I use for my Georgia Highlands email and everything else. You get the Duo security. and then it finally opens up. When it opens up, you have about 3 different screens or 3 different regions on the screen. On the left-hand side, you have the navigator pane or the navigator window, which is where it's going to keep track of all the different analyses that you've done in case you want to go back to one of them later. You can go back and select it. So this is just kind of going to be on the left hand side is going to be a running list of all the different analyses that you've done. On the right hand side, you have a split screen. The lower half, and I'm going to pull it up so you can see it. The lower half of the screen is like an Excel spreadsheet. It should look similar to a spreadsheet. You have columns and rows. Minitab, instead of labeling the columns A, B, C, D, like Excel does, labels them C1, C2, C3. C standing for column. Then the rows are also numbered, which helps me to know how many data values I've entered. The one thing that I like about Minitab that's different is notice how you have this gray area between the column number and the first row. This gray area is where I can indicate what information is in that column. And guys, when you're entering data, you should never, ever enter it without indicating what it is, because if I'm creating this spreadsheet today and I want to come back and use it on Monday or Tuesday or whenever, I need to know what information is in that column because I likely will forget. So for example, I might put your pathways. Okay. Now I usually continue without autosave. I don't usually save it to the cloud. If you have cloud space and want to save it there, you can, or if you have a Google Drive, you can. But notice how I just typed it in. I typed in the word pathway as my label, and then I would begin entering what your pathways are. So like I would have criminal justice, psychology, film, studies. I'd have another criminal justice, another psychology. So I just go down the list of majors. I got general studies. I have another psychology. Let me get these put in there. I have criminal justice, but it's the BS, but it's okay. I'm just going to put criminal justice. We have biology, whoops, misspelled it. I will tell you that Minitab is very case specific. So notice that I started typing and I have the first letter is capitalized. Criminal justice, which is 2 words, there's a space between. Minitab is very case specific. If I happen to type one of them differently, you know, like if I in the next let me put in political science, and then I put in biology, but I type it with a lowercase b at the beginning instead of the capital. Minitab reads that as 2 different things. So if you're entering the data yourself, it is very important that you enter it in a way so that you are consistent. You know, all of them are capitalized, you space where you space, because if you don't, Minitab will read it differently. Okay, also notice Okay, so you can, if you're given a data set, manually with your fingers, type it in, just like you would type things into a spreadsheet. Let's say that I want to put in your age, and we're going to put that in years. If you're using a unit of measure, you want to indicate what that unit of measure is. Okay. And then I could begin to enter the ages. If you don't mind, for those of you in the room, would you tell me your age? Nana, would you mind telling me?
Let's see, 25.
You're 25. Okay. Allison?
18.
Okay, somebody else came in. I didn't see your name. A couple more came in. Let's see.
Might have been me.
Gabrielle and Emmanuel. Emmanuel, how old are you?
19.
Gabriella?
26.
26. Okay. So again, as you, even in this case where you were telling me your age, I was entering them. Okay. So you can manually do that. It's just like a spreadsheet. Again, you always want to have this header to indicate what information is in that column. Also notice how now the C1 is C1-T. Minitab in some ways is smart, okay, because Minitab recognizes that the information that I typed into that column is words or qualitative data. Let me toggle back over here for a minute so I can make a note for you. The letter T in that column header, and I have a note here about it. Okay, the letter T in that column header stands for text. Minitab recognizes that that column of data contains qualitative data. Minitab is also smart enough, since it's words, that it's not going to let you perform mathematical calculations on that list because it's words. Another one that you might see, sometimes you'll see a D. D stands for date. So if you've entered something that represents a date, Minitab uses the letter D for date. Again, that is likely going to be qualitative data, even though it may be numbers. It's considered qualitative data, and Minitab is not going to let you perform calculations on that list. In contrast to that, and I'll tell you my age since y'all tell me yours, I'm 54. So the age in years, again, notice it just says C2. Again, Minitab recognizes that that column is numbers. And so it would allow you to perform mathematical calculations with that column. Sometimes, if you have a really large data set, you may be given a file, and you can upload that file to Minitab. Now, in some cases, as I kind of did this morning, you have to use your fingers to type it in yourself. For some of the activities in this course, you will need to upload the file. I'm going to show you, for example. If we look at the lesson that we're going to eventually get to today on descriptive statistics, missing data, and outliers. For some of the examples that we're going to do in class, I've given you a data set, either in Minitab format or in an Excel format. You will also have to use a data set to answer questions on quiz 2. So I need to show you how to upload a file. Now I am going to demonstrate it here in the Zoom room, but I also have provided videos on how to do an Excel spreadsheet and how to upload a Minitab file. How do you tell the difference? Well, let me go back over here. Nope, that's not what I need. Okay. Typically with Excel, you'll kind of know that it's Excel, or you may have a file that has a .csv prefix. Okay. If you have a .csv prefix or an Excel file, you have to copy and paste from Minitab to Excel. And guys, we copy the entire spreadsheet and take the entire spreadsheet into Minitab. Okay, so I want to show you how to do that. So I'm going to use the example from the class. So I'm in Module 1 for the lesson, Descriptive Statistics, Missing Data, and Outliers. And I have the hospital comparison data in Excel format. Okay, I'm going to click on that link, and it's going to open. I'm going to put it on my desktop, that spreadsheet. Okay, I have to get it opened up. And I have this spreadsheet. It's already been typed by somebody into Excel, but I want to move it into Minitab. So I'm going over. You need to put your mouse in this little corner right here. Well, it's going to let me draw. Okay, I want to put it in this little corner where my row, see the plus sign? It won't let me draw my plus sign, and I'm going to click. When I put my plus sign in that corner box and click, notice how it highlights all the columns, and it also highlights all the rows. So I've highlighted everything, and I'm going to go to copy. Okay, so I want to copy. You can right click if you want and copy, or you can go up to the toolbar at the top and tell it to copy. So I want to copy. And I don't know if you can see it, but when I select copy, it's kind of like it puts little dancing ants all the way around my spreadsheet. So that lets me know that I've copied it. Then I'm going to go back to Minitab, and I'm going to get a new worksheet. Okay. This is also very important. Before you paste it, you want to put your mouse in that little gray area under C1. That's where you want your mouse to be. And then I'm going to tell it, right click and tell it to paste. And it has brought that entire spreadsheet from Minitab to from Excel to Minitab. Everybody okay?
Yes.
Okay. So that's Excel. Excel is pretty much a straight out copy paste. The biggest thing is getting your mouse in the right place so that it copies correctly. Okay. I'm going to then do the other one. Okay. For the other one, you have Minitab. Okay. And I'm going to go out to a different location because I want to show you a different file. Also demonstrate a little bit about your projects. Okay. Kind of do two things at once. So if I navigate over to Mini Project 1, for Mini Project 1, I have provided 6 different options for you to choose from. So there are 6 different data sets, and you may choose which one you want to use for every single project throughout the semester. Once you choose a data set, you're going to use it for everything. I tried to find some that perhaps relate to your majors. I have one related to crime, if you want to use that one for criminal justice. I have some on transportation, some on healthcare. I have tried, for those of you who are a film study major, I've tried to find one related to movies or films. I haven't been successful on finding one that has enough information. But the one that students kind of navigate to that's just kind of a fun data set is the U.S. President's physical data. Okay, and notice I have it in Minitab format. For Minitab, there are 2 different formats that you can see. And I have them indicated here on our paper. It's .mtw or .mpw. And it makes a difference which prefix, or excuse me, which suffix you have. .mtw means you have a Minitab worksheet. .mpw means you have a Minitab project. And again, that suffix makes a difference because that's going to help you know what option to choose. I suppose the W stands for worksheet and the P stands for project. Maybe that'll help you remember. Okay, those 2 suffixes, if you have a .mtw file or a .mpw file, those are specific to Minitab. So let me show you how to upload that to Minitab. Please listen carefully, because this is usually one of the biggest questions I get. Students will panic and they'll email me. Okay, when I click on this file that says use this file and it's in Minitab format, I'm going to click on it and it's going to download it, but I want to put it somewhere where I know where it is. And notice this one is Presidential's Physical Data.mpx. And I'm sorry, I got the wrong letter at the end of this one. I'm sorry, that's my fault. Let me see if I can fix that for you. Okay, but I want to put the file somewhere where I know where it is. And I'm going to tell it to save it. Do not try to open it on your desktop. It won't open. It is specific to Minitab. You have to upload it to Minitab before it will open. If I go over here, see it says Windows cannot open this type of file. I know that. It's okay. I tell it okay. But it has downloaded to my desktop. Okay, Presidential's physical data. Right there it is on my desktop. I know that Windows is not going to open it, but Minitab will. So then I'm going to Minitab. And I'm going to go File, Open a Project. And I choose Project because it had a .mpx at the end. So File, Open a Project from a local file because it's on my desktop. I tell it OK. And then I have to choose the file. And it is Presidential's physical data, President's physical data. And it automatically populates into the spreadsheet. Okay. Now, again, I've tried to walk through them slowly here in our discussion. Okay. But also under the descriptive statistics, missing data, and outliers lesson, I have videos where I walk through it again. Specifically, there's one for Excel and there's one for Minitab. Okay, any questions? Because you're going to need to be able to do that as you begin working on your project. Okay, so I'm going to pull up a data set and we're going to talk about how to create a bar graph. Okay, let me kind of review and bring us up to speed. In the last class, we were talking about types of data visualization. And I want to focus this morning specifically on qualitative data to start with, and the graphs that you're going to be asked to create. For qualitative data, the one graph that you're going to be expected to create is a bar graph. A very simple bar graph. We're not going to get fancy. It's just going to be a regular bar graph. The important things to remember when you're creating a bar graph, Minitab is going to do the work for you, but it's important that you remember that you need a very descriptive and detailed title, and you want to make sure that you have your vertical and your horizontal axes labeled. Now, Minitab does a lot of that work for you. Okay, but there are a few things that you have to do for yourself. So I'm going to pull up a completely different data set. I don't want to use the president's data in case some of you want to do that for your project. So I have a file of information related to the passengers on the Titanic, and I'm going to use it this morning. Maybe. Got to get it pulled in. And my Titanic. Well, I know it's there. Give me just a minute. It's hidden on me. Cancel. Okay, it's a .cvs, so it's a Microsoft, it's an Excel file, so I've got to copy and paste. So I found it. I'm going to copy. And then I'm going to Minitab, and I need a new worksheet. Okay, one of the things that you may want to do when you first look at a data set, okay, is you may want to kind of figure out what information you have. So I have passenger ID, I have survived, and it looks like I have zeros and ones. Okay, so they're using a coding system, and I'm not sure which one is which, but let's say for perhaps 0 means that they did survive and 1 means they did not. So it's like a yes, no. P class would be, you know, what class were they as far as the ship? Were they on, you know, class 1, class 3? Because again, it looks like it may be a coding system. It goes 1, I see 1, 2s, and 3s. Then you have the name of the passenger. You have the sex or the gender. You have the age. You have how many people they were traveling with. Were they siblings or spouses? I forget what C8 is. I forget what that part stands for. It gives you the ticket number, how much they paid for the ticket, the cabin number. I can scroll over, and it gives you where did they embark, and the S, the Q, and the C stands for the different places where they stopped, where the Titanic stopped. And again, I forgot to write those down this morning, so I don't remember what they stand for. But again, you may want to kind of investigate what information you have. Again, I can see that column 4 has text, column 5 has text, column 9 has text, and column 12 has text. Okay. So that helps me to know in terms of which columns can I use to create a bar graph, because a bar graph applies only to qualitative data. Okay, so we're going to talk about how to create a bar graph in Minitab, and then also kind of begin to think about how to analyze it. Now, why do we need to do that? Well, one is you when you display the data, and you're writing your report or you're preparing a presentation, you want to be able to communicate what information is on that bar graph. Now, we talked about last class how that the pictures communicate a whole lot more quickly than the words. But again, you still want to be able to communicate that. You are going to be expected to do that on the first project. Okay, so let me kind of get you introduced to the first project, and then I'm going to demonstrate what you need to do. Okay, so for the first part of the first project, you guys, you have to tell me what data set you're going to use. Okay, for example, if I were doing this assignment, I would say I am using the Titanic passenger data set. I do ask in the instructions that are in D2L that you use complete sentences. Then I ask you to identify the qualitative variable that you're going to use to complete part 2 of this project. Okay, so I need to choose a qualitative variable. Okay, I'm going to choose, and I wish I knew what they stood for, and I may try to look it up here in a minute. I'm going to choose where they embarked. Okay, I'm going to use again, you're going to write a complete sentence. I will use the embarked data to complete part 2. And then I ask you, what is the sample size? And then what is the level of measurement of that particular data? Okay. I haven't shown you how to get the sample size yet, but one option, okay, is if you look at this spreadsheet, remember it has the rows are numbered. So if I scroll to the end of the document, and it keeps populating, okay, I keep scrolling to the end of the document. When I get to the last row, it's going to tell me that. Now, there may be some missing. Okay, I'll show you a better way later, but for now, I can scroll. And I have to keep scrolling. I think there's about 2,000 of these. Maybe not. Okay, it quit populating on me. Oh, did I erase it? Surely not. Okay. Okay, but let's just say I'm just going to make up a number to save time. Okay. I know that there was, just from what I know, there are 2,223 people on the, we could say people or passengers on the Titanic. Okay, well, the embarked, it is qualitative because it's words, or in this case, letters. And since it is words, it's qualitative, so it's either nominal or ordinal. There's really no sense of order to it. Remember, nominal means, or ordinal means there's order, so there's no order. So I would say embarked is at the nominal level. Okay, it's just a list of words. Okay, then you're going to do the same thing for a quantitative variable, but we haven't got to quantitative yet. Okay, so you have to identify the data set, identify the variable you're going to use, that's qualitative, and then I'm going to skip down to part 2. In part 2, you have to create a bar graph using Minitab. It says be sure to include title and labels on the X and Y axis. And then I remind you, the bar graph should be easily understood by any person without prior knowledge. Okay. And then you have to kind of summarize what you've learned. You have to explain what the chart tells you using complete detailed sentences. Now, guys, I really, really, really do not want you to go down through here and answer these questions one at a time. These are guiding questions. These are the things that you might want to mention in your summary. I would much prefer that your summary be like a paragraph, not just answering these questions. Okay, because if you're writing a report, you're going to be writing most likely paragraphs to accompany the pictures. Okay, so we're going to create the graph, and I have the clicks that you'll walk through in Minitab to create it. So I'm going to pause it there for just a minute. Okay, so you can make notes of those, write it down. It is on the notes for today, and so I will post it. But if you want to take some quick notes, you can. And I'm going to see real quick if I can find out. where the Titanic stopped so we can know what those letters stand for. Everybody okay? I'm going to show you how to create the graph now.
Yes.
Okay, so we've got our data set. We've decided which variable we're using. And guys, Minitab is pretty self-explanatory. I didn't mention earlier, but the top half of the screen is kind of your workspace. This is kind of like your blank page. And then at the very top, you have your menu bar, very similar to what you see in Microsoft Word, Microsoft Excel, or so forth. And from my perspective, Minitab again is kind of common sense, okay, which makes it user-friendly because I want to create a graph. So I'm going to go to the menu at the top and choose graph because that's what I want to create. I want to create a graph. And then it gives me a drop-down list of all the different kinds of graphs that Minitab will create. So I'm going to scroll down this list until I find the option of a bar chart because that's what I want to create. In Minitab, it's called a bar chart. And I'm going to click. And Minitab will do it from a variety of ways. It'll do it from what we call the raw data, just the random list like we have. It'll do it in terms of an equation, or it will do it if I've already kind of summarized the data. We will be using counts of unique values because we have the random list of data. Once you make your selection, Minitab pops up kind of this little wizard type thing that literally walks you through the process. We will only be using one variable. That is the expectation. You're only going to do one. So I choose one variable and I have to double click here. And then it pulls up my list and I have to identify the categorical or the qualitative variable. I wanted embarked, which is in column 12. Then I'm going to use this options button and I'm going to click the box next to data labels, and I'll show you why we do that in just a minute. And then I'm going to click OK and OK again. And within Minitab, okay, within Minitab, it creates my graph. It by default indicates that the horizontal axis is embarked. And it has the count or the frequency. Those are the defaults. You may leave them that way. But guys, chart of embarked is not a detailed descriptive title. Remember, you want the graph to be able to stand alone. You want to be able somebody to look at it and know exactly what it's about. So I'm going to change this title. Notice here in the upper right hand corner, there is this upside down black triangle. I'm going to click on the triangle. It gives me graph options. So I'm going to choose options. And at that point, it lets me change what the title is. Now I can add a title, a subtitle, and or a footnote. Okay, so like for this one, and you may not need to be as, you know, the details are important. So we have Titanic passengers embark location. Now, if you have a date, if you had a specific date, you might want to include the date. For this one, as a footnote, I looked it up, and since they're using a coding system, I might want to include what the different letters stand for. We had C, which would have been Cherbourg, France. Whoops, I spelt it wrong. So there were people that got on the boat there. We have Q, which was Queenstown, Ireland. And S is Southampton, England. So I might want to include, since it's a coding, I might want to include that as a footnote. There's one that's got two that are unlabeled, and so those were missing. So we might say no label was missing data. Okay, once you have included your detailed descriptive title, you can add a subtitle, or if you need to add a footnote, we just close it. And notice it automatically changed it on my graph. And it added the footnote at the bottom, I would say. Let's see. Yes. Okay. Then I need to be able to share or copy this into my report. So to copy it, again, you use the triangle in the upper right-hand corner, and I click. And I'm going to copy. Notice how when I hit copy, it kind of put a black square around the graph. So I've copied it. I go over to my Word document and I can paste. And it pastes my graph there. Okay. So then I want to kind of summarize what's in what this graph is telling me. Okay, so the reason I had you mark the little box that says data labels is it then will tell me that the number in this blue bar above C is 168. Q was 77 and S was 644. Now I could probably add those together and get my sample size now too. But anyways, so now I want to do my explanation. So I might say this graph or this bar graph displays the location where passengers embarked the Titanic. It appears that 2 passengers were not identified or not known. We could say most passengers embarked in Southampton, England, which was the start of the voyage. Not that you would know that, but okay. Then we could say we could say 70. Whoops, I hit the wrong button. We could say 77, the fewest, embarked in Queenstown, whoops, Ireland. And then you could say, while 168 embarked in Cherbourg, France. Okay, so I mean, with a bar graph, depending on how many variables you have, the information, again, it's usually very straightforward. I've kind of said what information is there. A different observation might be that it appears 2 passengers were not known where they embarked. Maybe they snuck on. We've told the most, we've told the least. So, I mean, it's not a long descriptive paragraph, but again, I've kind of in words. I mean, think about it. If someone is maybe has difficulty seeing, you know, they have a visual impairment, you need to be able to, you are trying to explain to them what that graph displays because they can't see it. Okay. Now, I have just demonstrated the expectation for kind of part 2 of the first mini project. Do you have questions?
You said it doesn't have to be that long to display or summarize.
No, say I've got what, 1, 2, 3, I've got 4 sentences. Okay. Now, Nana, with qualitative data, that description or that summary is not necessarily going to be very long. I will tell you that the summary for quantitative, when we're dealing with numbers, will be lengthier, but I hadn't got to that point of demonstrating that part yet.
Okay. And what's that? In part 1, real quick, we don't do the quantitative yet.
You will eventually do the quantitative before you submit this assignment. You will have done both the qualitative and the quantitative.
Okay.
At this point, I'm trying to kind of give you the heads up or the example for qualitative, because that's the point. That's kind of where we are in terms of our discussions. I'm hoping, I don't know that I'll get to it today, but if we can, we'll look at the quantitative before class is over today. If not, we'll do that first thing Monday.
Okay.
But what I'm saying is this assignment is due on Friday, March the 17th. And so you could begin working on it over the weekend between now and Monday, so that if you have questions, I can try to help you.
Okay.
And at this point, you only have enough information or enough background to do the qualitative.
Okay. All right. Thank you.
You're welcome. Anybody else have questions? Okay.
Oh, no, I think I forgot to mention. Excel and Minitab, they look similar.
Yes, they are very similar. Minitab was created or is a better statistical tool. It does a lot more statistical analyses and stuff than Excel ever will. So they do look very similar. I mean, the spreadsheet itself is pretty much mimics Excel.
Okay. Okay.
Okay. Other questions?
No. Oh, actually, we can, what's that? Like after we pick our, what was that?
Data set?
Yes. And we make our bar graph. We can make our own title.
Yes, you should make it a very detailed title.
Okay.
So when you're thinking about giving it a title, think about who, where, what, and when.
Okay. All right. Thank you.
Mm-hmm. Anybody else? Okay, so if we go back to our agenda for today, so we've kind of walked through the introduction to Minitab. We've done our data display specifically for qualitative data, and I've tried to demonstrate the expectation for the first parts of Mini Project 1. So now we're going to move into the discussion of descriptive statistics, missing data, and outliers. And I'm going to use the PowerPoint that's available in D2L to do that discussion. Okay, so our focus now is going to shift to quantitative data. We did talk about quantitative data and the types of graphs we can create, okay, for quantitative data. The two that you're going to be expected to do are a histogram and a box plot. Okay, a histogram and a box plot. And I will show you how to do those a little bit later, because we need some more information really before you can interpret or summarize the box plot or even the histogram. So I need to give you some more information first. And that information is going to come in our discussion of descriptive statistics. Okay. So whenever you begin to analyze data, more specifically, when you begin to analyze quantitative data, there are 5 characteristics or 5 different things that you want to focus on and kind of ensure that you include in your summary. Those are the center. The center is a representative or average value that indicates where the middle of the data set is located. So the center looks at where is kind of the middle, or what people often refer to as the average, is located. Second is variation. Variation looks at how the data values vary among themselves. We could also compare data sets. If we have 2 or 3 different data sets, we could compare them. So the variation gives us an idea of how much the data varies amongst themselves or from data set to data set. Third is distribution. Distribution has to do with the shape of the data. Are all of the data clumped together on the low end, or are they clumped together on the high end, or are they clumped together in the middle? Do they all kind of seem to be the same? Outliers is the fourth. Outliers are data values that, quite honestly, just don't seem to go or fit with the rest of the data set. I always think about like a cow that's, kind of outlying in the field. It's standing way off by itself. It's outlying in the field. It's not with the rest of the group. And an outlier can occur either on the low end or the high end, or it could be you could have on both. It's important to recognize that you have outliers because the outliers can influence or affect the values you have for the center and the variation. And finally, the last one is time. Time, and hopefully it makes sense to you that data changes over time. For example, if we looked at the life expectancy of, of people, say in the 1800s, and then we looked at it again in the 1900s, and a third time in the 2000s, I would dare say we would get different values as the technologies and medicine and different things have increased or improved. The life expectancy, I would anticipate, has also increased over time. Time is usually the one characteristic that we do not focus on in this course, for the fact that it's an 8-week course and we can't talk about something changing over an extended period of time in 8 weeks. All of this information should hopefully sound familiar, because all of this is kind of a review from Stat 1401. So our focus is primarily on center, variation, distribution, and outliers. So let's talk about center first. There are 3 different measures of center. They are the mean, sometimes referred to as the arithmetic mean, and it is the most important of all the different measures of center in describing a data set. Okay, it's most important of all the numerical measurements. It's the most important because it uses all of the data values, and we use it in other statistical calculations, such as the variance and the z-score. So of the 3 measures of center, the mean is the most important. So if I were limited, or if I had to do calculations by hand, I would likely try to determine the mean. The mean is what most people think of when they hear the word average, because the process for finding it is adding up all of the data values and dividing by how many you have. The mean is unique to the data set, but as I mentioned, it can be affected by those outliers. If you have several values that are just really, really a lot bigger than the rest of the data, that can cause your mean to be inflated or higher than it should be. Or if you have really, really low data values, that could cause the data set or the mean to be lower than you would expect. So you have to be careful. The mean is the best of the 3, but if I have outliers, I may want to use a different measure of center. Typically, if I have outliers, then I would go and try to use the median. The median is the middle value of the data set when you have the values arranged in order from smallest to largest, or vice versa. So I'm not really calculating, I'm simply locating the middle of the data set. So the median is not affected by the outliers, and it actually does divide the data set 50-50, so that you have 50% of the data below the median and 50% above the median. That's your 50-50 mark. And again, it's less affected by the outliers. The third one is called the mode. The mode is the data value that occurs the most within the data set. It is the only measure of any kind whether it's measures of center, measures of variation, distribution, outliers, whatever. It is the only measure that we use with qualitative data, because I can tell you which category occurred the most. For example, if you go back to the Titanic example a while ago, I know that most of the people embarked in Southampton, England. There can be, within a data set, there may not be a mode at all. There may not be a value that occurs more than all the others. It might be that you have just one. It's also possible that you could have more than one. You may have a number that occurs, or several numbers that occur the same number of times. Let's say you have two numbers and they each occur 5 times. So you would have 2 different modes. So it's okay to have more than one mode. So it is definitely not necessarily unique to the data set. Okay, so those are your 3 measures of center: mean, median, mode. Now, just as a side note, Minitab is going to calculate all of these. We will use app.minitab.com to calculate the measures of center: the mean, the median, and the mode. Notice that those 3 measures all start with the letter M. The measures of center are the M&Ms. Okay, then we have the measures of variation. How much do the data values differ amongst themselves? The range is very simple to calculate. It is the maximum minus the minimum. You know, sometimes when you're reading an article, it'll say the data values ranged from. We think about the ages from our earlier discussion. I would say the range was from 18 to 54. And so I could subtract those 2 numbers and get an idea. Okay, so the range is easy to calculate, and then you got to, think about, well, how do you interpret that? Well, it's somewhat relative, but, if you get a small value, say like 5 for the range, that kind of seems that your values are reasonably close together or grouped close together. But if I get a range of, say, 50, a range of 50 would indicate that the data values are spread out across a wide range of data. Okay, the second one is variance. Variance is a much more useful measurement of the variation within a data set, because what the variance does is it looks at each individual data value in relationship to the mean. How different is each data value from the mean or the average? So the variance takes into consideration all of the data values. It's what we call in statistics an unbiased estimator, meaning that the value of the variance, remember in statistics, and I think we talked about this the other day, we take what we learn about our sample or our small group and we apply it, back to our big group. Well, when we do that with our variance, the variance tends to be right on target. The value that I get for my sample tends to hit the bullseye for the population rather than overestimating or underestimating. So the variance is great or a very useful measurement, but it has a very big issue or disadvantage. Because of the way that it's calculated, your units of measure become squared. So again, if I were thinking about the ages in years and I were calculating the variance, we would have to talk about the age or years squared. Or if we were talking about money, we would have to talk about square dollars. And that's a very odd concept or thought. We don't normally think about those particular type measurements being squared. So the challenge with the variance, while it is probably the most useful and really the best because it is an unbiased estimator, it's difficult, if not impossible, to interpret. So we don't tend to use the variance as much. What we do use is called the standard deviation. The standard deviation, by definition, is the square root of the variance. So the standard deviation is literally the square root of the variance. And when we take the square root, that puts us back into the traditional units of years or dollars or whatever it is we're talking about. So we tend to use the standard deviation more so because it gives us a measure of how much we might expect a typical member of the data set to differ from the mean. Ultimately, the standard deviation is an average of the difference. We look at how each data value compares to the mean, and then we average those values together. Now there's a fancy dancy formula that I'm not going to show you because Minitab's going to do the work for us. But the standard deviation is a measure of how much we expect a typical member of the data set to differ from the mean. How, like, think about it similar to the margin of error. How off are we? Again, the greater the standard deviation, the more the data is spread out or varies. Again, so you got to think about it. Is this a small value or is this a big value? And again, it may be relative to your data set. Okay, but the bigger or the higher the standard deviation, the more the data is spread out. Standard deviation, guys, is never negative. So if you're ever doing the calculations and you get a negative number, then you know that you've made a mistake. Again, you are not going to be expected to calculate these by hand. Minitab will calculate these for us. We use the software or the statistical software package to do the calculation so we can focus on what does that mean and how does it help us. Then we have the measures of position. Measures of position, there are primarily two. We have a subcategory, so within that subcategory, we really wind up with three. You have percentiles. Percentiles are used a lot, especially in the education field and in health-related fields. And it looks at, again, how an individual value relates to the group. probably most of you at some point, maybe in your educational background, have taken some sort of standardized test like the SAT or the ACT, or the graduation exam, those kind of things. Those tests, usually when you get a report back, will tell you your percentile rank. Okay, with a percentile, it divides our data into 100 equally sized groups, and each group contains 1% of the data. Okay, so the percentile rank is a way to compare an individual to kind of what we consider the national norm, or to the population. We compare your score to everybody else that took the test, or we can compare one data value to all of the data values. It's important that you understand how to interpret a percentile. And this is kind of a different concept that sometimes troubles students. The percentile is the percentage of the data values that fall below that specified rank. Okay, it is the percentage of data values that fall below a specified rank. And there's lots of different ways to calculate percentiles, depending upon the researcher, depending upon what assumptions we want or can make about the data set. And so we don't actually calculate percentiles in this particular course, but I do want to kind of give you an example of how to interpret it. Let's say, for example, my daughter took the Georgia milestones and she scored, I don't remember how those are scored, but let's say she scored in the 93rd percentile for reading. Okay. Well, what that means, and it's important that you know that, especially if you're an education major, because you may have to explain test scores to a parent. If you are perhaps going into a health-related field, even psychology with IQ scores, those kind of tests use percentiles, and you may have to explain that to a parent or to a guardian one day. Okay, so a 93rd percentile means, okay, that 93% of all the students who took the reading milestone exam scored below Miss Ralston's daughter. Okay, the key to interpreting a percentile, it is the percentage that is below that given score. So 93rd percentile, that's pretty good, because that means she scored better than 93% of the people that took the test. Again, we don't really calculate the percentiles, but you may be asked to interpret them. What we do calculate are called quartiles. Quartiles are a special type of quartiles that divide the data set into quarters, or into 4 groups, where each group contains 25%. Okay, so with quartiles, you have 4 groups at 25% each. One of the reasons we talk about quartiles in this course and we calculate the quartiles is because quartiles will help us to determine if any outliers exist. And remember, outliers is one of the important characteristics that we need to address. So quartiles help us to determine whether we have outliers or not. The value may or may not be part of the data set. It may be, again, based on the calculation. Again, it is still the percentage below. So for the first quartile, and the symbol is a Q with a subscript of 1, is 25% of the data fall below Q1, and then 75% would be above, because if you have the whole data set's 100%, so you would have 25 below and 75 above. The second quartile is actually the median, and it divides the data set 50-50. The third quartile, you have 75% below quartile 3 and 25% above. Again, it's important that you understand it is the percentage below. And if you're thinking about quartiles, think about quarters. 1 quarter is 25%, 2 quarters is 50%, 3 quarters is 75%. Now, we will use Minitab to find quartiles. Okay, we will use Minitab to find quartiles. Within the quartiles, we also have something called the interquartile range, which represents the middle 50% of the data set. Again, Minitab, I'm going to make a note here. Minitab will calculate that for us too. And it's called IQR. Interquartile range is abbreviated IQR. Interquartile range. And that's in my way. There we go. Get out of the way. Okay, so there are different ways to display the descriptive statistics. We can create tables. We can do it a quantitative frequency distribution, which organizes the raw data, gives us an idea of how many are within each group or category. We can use various types of tables. We can create, it may just be a list of the mean, the median, the mode, the range, the variance, all of those statistics. There's one that's very common that you see. It's called the 5-number summary. The 5-number summary is the minimum, quartile 1, the median, quartile 3, and the maximum. And then we also add the mean, the standard deviation, and the sample size. Guys, of all of the different things that we described, I told you that the mean was the most important. The second most important is the standard deviation. For the same reason, the standard deviation uses all of the data values, but it's also used in other statistical calculations. So again, if I'm restricted on what I can calculate, I definitely would like to calculate the mean and the standard deviation if possible. Again, then we also can display descriptive statistics or quantitative data using a histogram, a line graph, or a box plot. Again, the two that you're expected to know are a histogram and a box plot. And then I just give you some examples of different ways that data is displayed. Okay, various ways you can set up a table. I give you some examples of the graphs that you can create, histogram and box plot. Okay. A couple of other things. One of the things that I did not address, okay, and let me stop the share so I can get out of this PowerPoint. One of the things that I did not address, we talked about measures of center, measures of variation. We didn't talk about distribution. So I want to address distribution, and then we're going to actually do some of this. Okay, so let me go back to sharing. And we're going to make some notes about the distribution. There are lots of different distributions that we could discuss. Okay, we're going to talk about kind of the three broad categories. Again, there are lots of different ones. We can get very fancy dancy with the names. We're going to keep it as simple as we can and talk about the three broad categories. The first one is called skewed to the left. Okay, it doesn't matter which one I start with. So skewed to the left. Visually, for a distribution that is skewed to the left, if you're looking at it, say on a graph, whether it's a bar graph or a histogram, okay, your graph usually runs low to high, and for it to be skewed to the left, you would have very few data values on the low end, but you have lots of data values on the high end. Okay, so skewed to the left, you have very few data values on the low end, but lots of values on the high end. Now, I just rough sketched that in kind of a thinking about it in terms of a histogram. If we think about it in terms of a box plot, for skewed to the left with a box plot, the box is going to be on the high end. Okay. And when we think about the distribution, we usually think about it from two different perspectives. I initially think about it with my eyeballs. I initially think about it from a visual perspective. So I can do a visual inspection and kind of use my eyes and my gut to think about whether I think the graph is skewed to the left or the other options are symmetric and skewed to the right. But sometimes, guys, it's so close that you just really can't tell. All five of us could maybe have a different opinion. Okay, So we also have an algebraic verification. Okay, there is a way where we can prove beyond a shadow of a doubt that the distribution is skewed left or skewed right. And we do that by comparing the mean and the median. We can include the mode, but sometimes the mode kind of messes us up. So if a distribution is truly skewed to the left, our mean is less than the median, which would actually also be less than the mode. But again, the mode, sometimes if you've got more than one mode, it can mess things up. So focus primarily on the mean and the median. And if it is truly skewed to the left, the value, the number of the mean will be less than the median. The second distribution that we talk about, or that you need to be familiar with, is symmetric. Okay, with a symmetric distribution, and you look at it graphically, again, your graph usually runs low to high. Visually, it looks like you have most of your data in the middle. So for a symmetric distribution, most of the data values fall in the middle, with very few on the low or high end. If you're looking at it from a box plot perspective, with a box plot, the box would be in the middle of the graph. Now, again, it's not going to be an exact science, guys. Okay, it's not going to be an exact science, but then you can prove it by looking at the relationship of your mean and your median. For symmetric, the mean is approximately the same as the median. The values are all the same. The mean, the median, and even the mode. But again, and it's an approximation. They're not necessarily going to be exactly the same. It's approximately. The third distribution that I want you to know, or that you need to know, is skewed to the right. Okay, with skewed to the right, again, looking at our graph, you're going to have lots of data on the low end, but very few on the high end. Okay, so for skewed to the right, you have lots of data values on the low end and very few on the high end. With a box plot, your box would be on the left or on the low end. And in this case, the mean is greater than the median. Okay, so those are the three. Yes, ma'am.
I was gonna say, in the symmetrical, it looked like the bell-shaped graph.
It does look very much like a bell-shaped graph. It doesn't have to be bell-shaped. Another way that I could have drawn it, just so you can see it, let me put it in a different color. Another type of symmetric graph, I could have drawn something that looks like this, because that's still symmetrical. Remember, the idea of being symmetrical is that the left side is a mirror image of the right side. So it doesn't always have to be bell-shaped. Typically, that's the most common one used, Nana, but not necessarily. It could be a rectangular shape.
Okay.
Or
And
you could even have, I mean, it could be upside down. You could have kind of from algebra, you could have that quadratic or that U shape. So it doesn't have to be bell-shaped. Again, that's probably the most common one we see, or most common one we use in statistics.
okay. And the mean doesn't always have to be the same as the median?
To
Or
be
maybe close?
symmetric, the mean should be approximately equal to the median.
Okay. Like close to the
Close,
median? Okay.
close, yeah.
Okay. Thank you.
Other questions? All right, let's see if we can maybe put all this together. And while we're looking at an example, I want to also address what you need to do for the mini project 1. Okay, so now our focus is on quantitative data. Okay, now our data value, we're on quantitative data. So if I go back to our data set that we were using earlier this morning, okay, and I want to use, no, because it's going to make it go away. But I have to pick a quantitative variable, and I'm going to have to pull my data set back in again. I'm sorry. If you don't use Minitab for a while, it will automatically time out, and mine has. So let me go back and get our data set again. I'm sorry. But let's maybe for this time, let's use the age of the passengers. Okay, so if I'm thinking about working on project 1, you've already told me that you're going to use the Titanic passenger data set. Okay, so now I'm at question 3 under part 1. It says identify the quantitative variable. So I'm going to change colors. I would say I will use the age in years of the Titanic passengers to complete part 3. Okay, and again, it wants to know the sample size, and I'm going to show you how to get that without having to guess here in just a minute. The level of measurement for the age is quantitative, so it's either got to be interval or ratio. It is actually ratio. Age is at the ratio level, because if a person is 0 years old, they technically do not exist yet. They haven't been born yet, because as soon as you're born, the first second you're out of the womb, you're a second old. So if they're 0, they do not exist. They haven't been born yet. Okay, we'll come back to sample size. Y'all don't let me forget. Okay, then we go down to part 3. Part 3 says create a histogram using Minitab. So the first thing I want you to do is to create a picture or a graph of the data. We've picked age. Okay. Now, I don't have the keystrokes typed out for you this morning, but let me show you. For anything we do in Minitab, if you are on the course homepage in D2L, if you scroll under the content, there is a folder, Minitab Instructions. Under Module 1, I have the instructions for the Minitab graphs. Okay. I have the qualitative data bar graph. Then I have quantitative data for the histogram. So the information is available in D2L. I'm just going to walk you through it as slowly as possible so you can see the clicks. Okay, so I need to create a histogram. Again, the histogram is a graph. So I'm going to go to my top menu bar to graph. This time I want to create a histogram. So I'm going to scroll the list until I find histogram. I'm going to click on it. Now, guys, we're going to keep it as simple as possible. We're only choosing one value. So we have one Y variable, and we want it simple. We're not getting fancy. We're keeping it as simple as possible. You have to double click here. Then I have to choose my Y variable. We chose age. Let me check options. I don't think we need anything under options. Nope, we don't. Okay, so once you choose your variable, you click OK. And again, in the top half of the screen, Minitab creates the histogram. Minitab uses the midpoint for each bar. It labels the axes. So my horizontal axis is age and the vertical is frequency. I didn't show you this earlier, so if you'll kind of pay attention here for a minute. If you're in Minitab, your graph is somewhat interactive. If I scroll over and put my mouse on the first bar, it tells me that that first bar really represents the ages from -1 1/4 to +1 1/4. Now, guys, you know that people cannot be negative ages. So technically, the lowest age we could have is 0. And my highest value, it looks like this last bar here is at 81.25. So the ages ranged roughly from 0 to maybe 81, 82. If I want to know, the highest bar here, most of the people were in the age 23.75 to 26.25. So if you're in Minitab, it's interactive. You can scroll over the bars and get information. Now, once I copy it and move it out of Minitab, I lose that interactivity. But again, our title needs to be descriptive, detailed and descriptive. Again, think who, where, what, when. So again, I have to use the little black triangle in the upper right-hand corner. Click, choose graph options, and I'm going to put in my histogram. Okay, I'm going to put ages, age, in years of Titanic passengers. Okay, again, I've told you what I've measured, how I measured it in years, and who it was, Titanic passengers. If I had the dates of when the Titanic sailed, we could put the year or stuff in there. But again, try to make the title as detailed as possible. Who, where, what, when. Same process as before. Once I have everything fixed, I'm going to copy it so that I can take it over and paste it into my document. And again, then I want you to summarize it. Now, again, here I give you some things to say or some guiding questions. Again, I don't want you to just answer these questions. Okay. So again, we might say for this graph, if I'm summarizing it, okay, I might say this histogram displays the ages in years of the Titanic passengers, which range from approximately 0 years old to, and I may have to go back to Minitab, and I notice this last bar is at 81.25. So I might say up to 82 roughly, okay? Because I've said approximately to 82 years old. The histogram appears to be, let's see. You got to think about, do you think it's, skewed left, skewed right, symmetric? To me, it kind of looks like it might be symmetric. I'm saying it appears to be symmetric since many of the passengers were between, you could say were what we call were middle-aged. Other things I ask you to do, what value appears to be most common? Do there appear to be any outliers? So most common, think about it on the histogram, is going to be the bar that's the tallest. So again, if I come back to Minitab, the bar that was tallest, it appears that there were 72 people between the ages of 23.75 and 26. So I might say between 23 and 27. So I could say, whoops, most passengers were between the ages of 23 and 23 years and 27 years. Make sure to include your units. There do not appear to be any outliers. Outliers, remember, are the data values that just don't seem to fit. Okay, just don't seem to fit. And I don't really have any. I mean, there's a few little breaks in here. Okay, if I come over again, this bar between 66 and 68 would be 0, but I still have a few out here. Okay, up to 81, 82. So, but it doesn't really seem like there are any outliers because there's not like a huge gap or break in there. If I want to make other observations, I could say that, you know, most people were, there were very few that were of retirement age because there, you know, there's not very many over the age of 66 or 65. Okay, so that could be an observation I make, that there were very few passengers, only a handful of Titanic passengers were over the age of 65, say, you know, because I can see there's not very many out here on the end. So again, it's only, I've got what, how many sentences here? 1, 2, 3, I got 5 sentences. Okay, so it's really not many more than we had before, but I've kind of addressed all of these questions. Now, if you get some data and it's got some really interesting observations, you can add more sentences. Again, if you were writing a report, you would want to include that because that makes your report interesting. It lets people know. Again, what you're trying to do is share what information is on this graph, thinking about somebody who can't see it. Questions?
For histogram, they're supposed to be outliers.
Not necessarily. It really totally depends on the data.
Okay.
And at this point, Nana, I'm just looking at it visually from a visual perspective. Later, I'm going to show you a way to prove it. Okay? But based on what I see with my eyes, I don't think there's any outliers here.
Okay. But how can you tell if there are no outliers visually?
Well, because there's not like a huge gap in my data here. See, there's a little bit of a break, but for the most part, I have data in every group from the beginning to the end.
Yeah.
I don't have a huge break, and I don't know if this data set, let me see if I can graph a different one and see if we get a, maybe we might, let's see. This is the fair. See, look here. See this one here? See
Yeah.
how right here through here there's like nothing?
Yes.
And then you got this one value that's way up here.
Yes.
Okay. This, to me, I would think this one that's way up here by itself is an outlier.
Okay.
And I can kind of tell that visually because there's this big gap in my graph.
All right.
Okay. Other questions?
And don't forget the sample size. You told us to remind you.
Oh, I hadn't got there yet.
Okay.
Thank you for reminding me.
You're welcome.
Anybody else before we move on? Again, I'm trying to kind of do two things at once, show you the example and show you how to do it at the same time. Okay, so we finished with that graph. Then I ask you to create the box plot, and then we're going to summarize what it says. Okay? But before we create the box plot, I want to skip down here to number 5. I'm going to skip to number 5 first because we need to be able to find this 5 number summary because we're going to need it when we're doing the summary. So I'm going to skip down and show you how to do the descriptive statistics first. Okay, this particular question here, and I'm just going to make a note, addresses the descriptive statistics. And it's not actually asking you to find them all, but I'm going to show you how to find them all because Minitab does it with one single command. It is so nice. I don't have to calculate them individually. So again, we already have our data. We're still using age. You're not changing variables. If you pick age in part 1, everything you do in part 3 is related to the age. You don't change the variable. Now, if you're doing your homework, you may have to change the variable from question to question, okay? But we're going to use the same variable the whole time for our problem. Okay, so here's how you do descriptive statistics. It's going to calculate those measures of center, measures of variation, and so forth. Okay, so we go to stat, because I want to calculate descriptive statistics. I want to do basic statistics, and I want to display the descriptive statistics. Okay, I want to display the descriptive statistics. Oops, I didn't click it. Okay. Then I have to tell Minitab what column or what data do you want me to calculate with. We're doing age. So I'm going to go over here to this left-hand column and I'm going to put my mouse on age and I'm going to double click. Doo-doo. It automatically pops the word age into my variable list. Okay. Then we're going to use this button that says statistics. I want to tell Minitab all the things I want it to calculate. Some things it calculates by default. I'm going to check them all and then I'll read through them and you can make notes. You don't have to memorize this list. Okay? You do not have to memorize this list. The list will be in the question, on the test paper, on the project. It'll tell you what you need to calculate. But typically, these are the things we calculate. The mean, the standard deviation, the variance, first quartile, median, third quartile, interquartile range, mode, minimum, maximum, range. And then this is important. You want to click the box in missing and in total. And then I'm going to click OK, and Minitab is going to calculate them all for me at the same time. Boom. Boom. And I have okay, let me go back. Let's click one more box. Let's click in non-missing. Instead of in total, do in non-missing and in missing. Don't do in total. Okay, Nana, you just asked me and reminded me that I said I was going to show you how to get the sample size. I now have the sample size because the sample size is 714. But I had 177 pieces of data that were missing, meaning I didn't know the age of 177 passengers. Okay, so I'm going to copy this over to my page so we can talk about it just a minute.
Okay.
Okay, so I'm going to put this right here. And let's see if I can make it spread out some. Well, I didn't want it to spread out that much. Okay, I was trying to see if I can make it spread out just a little bit because it's got my numbers kind of jumbled up. Okay, maybe we can see them all here. Okay, so first of all, right here, N is 714. That is your sample size. It kind of got over my. Okay, so the N is your sample size. So now I could go back up at the beginning and say there are 714 passengers, passenger ages given. Okay, so now I know how many I have, and I could tell that from my display. It also tells me, because sometimes in a data set, when you're collecting data, maybe somebody doesn't respond to one of your questions, or you can't read their response, or their response maybe is not what you were looking for. So you have to document if you have missing data. Okay, so N star is your missing data. In this particular problem, there were 177 passenger ages that were unknown. They weren't given. Maybe they didn't report it, or they just couldn't find that information. So you're missing. And when you're reporting or doing your own research and writing a report, you need to indicate that you maybe didn't use certain data because you were missing certain pieces. Okay, the rest of it, honestly, if you look closely, is clearly labeled: mean, standard deviation, variance, minimum, Q1, median, Q3, maximum, range, IQR, and the mode. Now, there is, let me show it to you in Minitab. At the end, you'll see this little value that says N for mode. My mode, the age that occurred the most was 24. And there were 30 passengers who were 24 years old. This N for mode, okay, just tells me how many were that particular age.
The
Okay,
sample size,
ma'am.
from the sample size, the N for the mode, that was from the.
N for the mode is the sample size of the mode.
Yeah, I was
Yes,
I
yes,
was asking that.
yes, yes.
Okay.
Okay, now specifically for this question, I ask you for the 5-number summary, the mean, and the standard deviation. Okay, the 5-number summary, and I don't want to use the highlighter because it blacks it out. Okay, the 5-number summary is the minimum, Q1, median, Q3, and the maximum. It's those 5 numbers. This is the 5-number summary. And then you want the mean and the standard deviation. Now, how you choose to display that is up to you. But guys, it is more than just copying it from Minitab. You can write it in a sentence and say the minimum is 0.420 years. Quartile 1 is 20 years. Median is 28 years. Quartile 3 is 38 years. And maximum is 80 years. The mean age is 29.699 years with a standard deviation of 14.526 years. Okay, you can write it in a sentence. If you want to display it in a table, like I just showed you on the PowerPoint a while ago, you can do that. Okay. It is more than copying and pasting the results from Minitab. You have to actually write it down. Now, everybody okay? Now I'm going to back up to the box plot. Okay, I'm backing up to the box plot, which is another type of graph. The box plot is a visual display of that 5-number summary. So I'm going to show you how to create it. Graph, box plot, keep it simple. I'm doing age. I don't think we need any options. We do not. So we choose the variable, click OK, and it displays. Now, again, this one, you only really have one vertical scale, which is the age. We do want to give it a detailed descriptive title. Same thing, using the triangle, graph options. I'm going to say age in years of Titanic passengers. Again, think who, where, what, when. Oops, sorry. Again, this graph is interactive. If I put my mouse over the blue box, it tells me the value for quartile 1, the median, the value for quartile 3. It tells me that my whiskers, the whiskers are these lines. So you have the box. This lower line represents Q1. The middle line is your median. And the upper line is quartile 3. And then you have this vertical line that runs out from the box. And it goes to 0.420, which was the minimum value of the data set. The other whisker runs out to about 65. And then you start seeing all these little asterisks. Guys, those asterisks are the visual display of the outliers. So even though when I looked at the histogram a while ago and I said, I don't think there's any outliers, looking at the box plot has visually indicated that these values where these stars are, this first star is at 66, that the age of 66 is an outlier. And then I have several others. All these ages up through here, 70, 74, 80 are outliers. So the whisker only comes out to the point where the outliers begin. The last outlier is at the maximum point. So the box plot gives us a little bit more insight to the data. And I'm going to copy the graph, and I'm going to go and paste it in Minitab. And again, I've got to summarize it. Again, I give you some hints on, what to say. Things to think about. Now, specifically, and this is the one students always overlook, this is the important one, is to interpret each quartile. And I'm going to do that for you in just a minute. Okay, so let's think about summarizing this graph. Again, kind of in using like a paragraph form. Again, this box plot displays the ages in years of Titanic passengers. The ages range from 0.420 years to 80 years. Now, again, think about how I got that number. My lower whisker goes to 0.42. The last value displayed on the graph at that last outlier is 80. So I know that they range from those, from that value. Okay. I can say there does appear to be outliers, or I could say any passenger over the age of 65 appears to be an outlier within the data set. The distribution of the box plot is, see, before I felt like it was symmetric. When I look at this now, I don't know, maybe, thinking about the box being in the middle, I could still say it's symmetric. I could say it's maybe skewed to the right. I'm going to say the distribution appears to be symmetric. The middle, or the median, is, and again, I can go over to Minitab. The middle is 28. Is 28 years old. Let's see. And then we want to interpret each quartile. Okay, so I'm going to show you how this is the interpretation of the quartiles. We would say 25% of the Titanic passengers were younger, because remember, it's below the age of, what was Q1? Q1 was 20. So Q1 is 20. So 25% of the Titanic passengers were below or younger than 20 years old. 50% of the Titanic passengers were younger than 28 years old, because that was the median. 75% of the Titanic passengers were younger than, and let's see what quartile 3 was. Quartile 3 was 38. Okay, so this is, I'm going to make a note here, Q1. This is Q2, whoops, Q2, which is the median, and this is Q3. And guys, that's how you always interpret those things. It's 25% of whatever, 25% of, you know, the data values are below 20, or 25, because that's Q1. 50% are younger than 28, which was the median. 75% are younger than 38. So you have to interpret the quartiles. Again, I've only got what? 1, 2, 3, 4, 5, 6, 7, 8 sentences. You're not trying to write me a book, but I've addressed these questions. I've calculated my test statistics, or my statistics. Okay. Then we want to verify. Remember, I told you visually the box plot shows that we have outliers. Remember, these values up here that are stars are outliers. And our box plot shows it to us visually. Okay, so this is a visual. But we want to prove that they really are outliers based on the numbers. And so question 6 here asks you to do that. And I give you the formula. There is an algebraic formula for determining. Okay, so this is the algebraic verification of the outliers. This is the proof. You can prove and leave no doubt that those particular values are outliers. If you didn't have that visual, this would be the way you would determine whether you have outliers. Okay. The formula is Q1 minus 1.5 IQR, any data value less than that. So let me see if I can draw you a quick picture of what's going to take place here. Okay. Basically what's happened is when you're thinking about, let me go over to another piece of paper. When you're thinking about the box plot, okay, and you've seen it created in Minitab, I'm going to rough sketch one by hand. We would have the minimum, and then we have Q1, then we have the median, you have Q3, and you have the maximum. And normally there's a box drawn around Q1 to Q3. That region between Q1 and Q3 is called the interquartile range, or the IQR. And Minitab has given us that value. So it's like we're going to start at Q3, and we're going to calculate Q1 minus 1.5 times the IQR. And whatever that value is, I'm going to put a fence post there. And if I have any values that are beyond that value, they're considered outliers. And then I'm going to do the same thing on the other end. I'm going to calculate Q3 plus 1.5 times the IQR. And anything that is beyond or outside that value is an outlier. So it's kind of like I'm putting up some fence posts. You have the formula on the worksheet on your project, so you don't have to memorize the formula. Okay. But I do need the values. Q1 was 20 and IQR is 18. Okay. So Q1 is Q1 minus 1.5 times IQR. So I've got those numbers directly from Minitab. Minitab has calculated them for me. So I have 20 minus 1.5 times the IQR of 18. Make sure you follow order of operations. Multiply 1.5 times 18, which I believe is 27, but let me make sure. Yep, that's 27. So you get -7. Well, again, we're talking about ages. You can't have a negative age. The youngest you're going to have is 0, possibly. So I don't have any outliers on the low end. But then if I consider the other end, we have Q3 plus 1.5 times IQR. Okay, and I plug those numbers in. Q3 was 38 plus 1.5 times the IQR of 18. All those numbers come from Minitab. We have 38 plus 27. 38 plus 27 is 65. So any person over the age of 65 is considered an outlier. Okay, any person over 65 is an outlier. I have just verified that. So there are outliers in this particular data set. Then question 7, the primary thing that I want you to do on question 7, if you've noticed some kind of maybe unusual things about your data, you can share them here if there's other things you want to address. But the primary thing I want you to do on question 7 is to verify the shape of the distribution. In both cases, when we looked at the histogram and we looked at the box plot, I felt like it was symmetric. Okay, so my eyeballs make me think that my distribution is symmetric from the histogram and the box plot. But I want to verify that. Okay. I do that by looking at the mean, the median, and the mode. Okay. My mean is 29. The mean is 29.699, I think. Let me go back up there and look. Make sure I got it right. 29.699. The median is 28. Well, to be symmetric, the mean should be approximately equal to the median. So then you have to ask yourself, is 28 and almost 30 approximately equal? I don't really think so. So then if I literally compare these two numbers, the mean of 29.699 is greater than the median of 28. And so if you go back and look at our distribution options, okay, when the mean is greater than the median, it's skewed to the right, that you have more younger people than you do older people. Okay, so by this number, our visual observation probably is incorrect. The distribution is really skewed to the right, which implies you had more young people on the Titanic than you did older people. But again, I mean, you know, we're really close there. So my eyeballs were deceived, but I can confirm that I was wrong, and it's really skewed to the right. So you would kind of write that up in a sentence that, you know, visually you felt like it was symmetric. However, based on the numbers, it is skewed to the right. Now, I hope that I've accomplished two things. One, I hope you have an understanding of descriptive statistics, mean, median, mode, range, standard deviation, all that. Minitab does all the calculations. You understand about missing data and finding outliers, but at the same time, you have a better idea of what the expectations are for the completion of Mini Project 1. I hope you will take the opportunity between now and maybe Monday to begin looking at Mini Project 1 so that if you have questions, you can ask them on Monday. That assignment is due by next Friday, which is the 17th of March. Quiz number 1 and quiz number 2 are due by Sunday. Quiz number 1 and quiz number 2 in your homeworks are due by Sunday. Any questions? I got a minute left.
The quizzes, that's like the questions are based from the PowerPoint.
The questions will be similar to the examples we've done from the PowerPoint. You can find them in a couple of different places. The easiest place to go is, whoops, let me share my screen real quick. Okay, if you're in D2L, the easiest way to get there is to go to Assessments, Quizzes, and then you'll see Quiz 1, Quiz 2. But it's going to be information, example problems related to the content on the PowerPoints and our discussions.
Okay.
Anything
Okay.
else?
No, I think that's it for me.
Allison, Gabriella, or Emmanuel, you have questions before we go?
No.
No.
All right. I will see you guys on Monday. If you have questions, you're welcome to email me, or I do have Zoom office hours on Sunday night from 8 to 9 p.m. Y'all have a good afternoon.
All right.
You too. Thank you.
Bye.